Hello everyone and welcome to the CloudWorld. This presentation is about property graphs in SQL. I would like to start by presenting myself. My name is Vlad. I'm a manager at Oracle, where my main focus of work is on scalable graph processing. I would like to start my presentation with a very interesting observation about the fact that connections are everywhere around us. You can think at your social network, at your bank transactions, the transportation network you are using, the supply chain network you are relying upon, all the interactions between us, those are all examples of connections. And graphs are just a powerful tool to leverage information stored in those connections. Recently, graph has become an important trend in data and analytics. Gartner has classified graph as one of the top 10 data and analytic trends in 2021. The main reasons why they are doing so is because graph give you intuitive abstractions to bring together data from various data sources and exploit signals stored in the connections in between those data sources. As an example, they show that graph can really help you boost the performance of AI and machine learning algorithms by providing interesting and latent insights hidden in your data. But what is a property graph? So very simplified, a graph is a set of vertices, sometimes called nodes, as you can see here on the right side of my screen, which are connected between them with edges. Okay, so in addition to this, both vertices and edges can have what we call labels. You can think of a label as being the type of a vertex or of an edge. For example, here you can see that we have two types of vertices, persons and companies, and then three types of edges. A person can work at a company, can be a friend of another person, or a person can just know another person. On top of labels, property graphs have properties, which are simply key value pairs, which can be associated to every vertex and every edge. But how is the property graph model different than a relational model? Well, in a relational model, connections are encoded implicitly using primary key, foreign key conditions or constraints, while in a graph model, connections are explicit. They are actually part of the data model in the form of edges. By modeling connections as edges in this explicit way, you will see later that this allows us to intuitively find patterns in the graph, right? By saying, I want to find the friends of a person, which then becomes a more intuitive computation to us rather than in a relational model where this would be modeled like a two series of joins. But graph is something that is fully compatible with relational, so it's just another view of your data on top, right? So graphs can enable a variety of new use cases. For example, in financial services, we can look at the various activity patterns in the bank and then try to detect suspicious patterns to identify money laundering, for example. In data privacy regulation, we can do data lineage tracking to understand, the various steps the data passes through in order to understand, how the data was used, copied, and utilized. So by modeling the various steps in the life cycle as vertices and the transitions between them as edges, one can walk those paths and understand, how the data was, from where the data originated, how it was used, and where it was copied, and so on. So professionals can fulfill all the GDPR requests. In addition to this, as I said also in the beginning, graph can help you extract useful information from your data, enrich, and then build features that can then enrich machine learning or AI algorithms. And at Oracle, we have seen an increasing usage of graphs across multiple domains. So we do have clients across all the domains you see here: finance, transportation, manufacturing, telecommunication, and many others. But why do people choose graphs first of all? And then I would like, via a really simple example, to show how graph can help you answer, model and answer certain questions in a more intuitive way. So assume you have these three tables on the right, where you have basically customers who own accounts and then the transfers between those accounts. And then we would like to answer questions like, are Bob and Charlie related? So, and if yes, is there any money flowing between them? Or, is there any money starting from an account owner and then originate and then flowing back to the same account owner, right? So if we just look at the data like this, and we try to answer these questions intuitively, they are not easy questions to answer, right? But if we model our data as a graph, you can see that we can immediately see the answers of those questions. So for example, we can immediately see that that Bob owns an account here, 1111, and then there is a money flowing up to an account which is then owned by Charlie, depicted here with the blue with the blue path, right? And then for the second question, you can also see that Alice owns basically two accounts, and then there is some money flow between those accounts. So potentially Alice can be flagged as a suspicious client for the bank, right? So this is seeing your data as a graph gives you a more intuitive way to express and answer certain questions, mainly related to traversals on those graphs, right? So in terms of property graph support, Oracle has been offering support for graphs since Oracle 12c. The main graph query language used for querying graphs is PGQL, property graph query language, which is a very SQL-like query language and which allows user to either run queries on the database by translating them to SQL, or run them in PGX, which is a mid-tier in-memory graph accelerator that can accelerate the performance of graph querying. On top of that, we also offer more than 60 pre-built graph algorithms that can allow you to do powerful analytics in PGX. So the products we are offering here are called ADB Graph and Oracle Graph Server and Client. Now, let's see what is new starting Oracle 23c. Starting Oracle 23c, graphs will be available in SQL. That's the big novelty. So users will be able to create a graph schema object and execute graph queries on it directly in SQL. That basically means that all the SQL clients, all SQL applications will be able to leverage graphs out of the box. And then all the existing graph applications that Oracle has been offering so far, in terms of notebooks, visualization tools, and so on, will be adapted to work with SQL graphs. Okay, so let's now see what is the property graph support in SQL about. So first of all, this will be, as I said, features starting with Oracle 23c. The SQL property graphs are a standardized extension of SQL called SQL PGQ. They basically offer two major capabilities. One is about creating a property graph on top of the existing data tables. The other one is about querying those property graphs using a new operator that will appear in the from clause of a SQL query called graph table. Now, one thing to notice here is that the graph creation, it doesn't imply any data copy. So the graph is created as a metadata object over original data. The graph will see the transactional consistent view of the underlying data. So there is no actual data copy. The graph is kept transactional consistent with the underlying data. Okay. The SQL property graphs strengthen the Oracle's converged database vision. You will see later that we will show some examples on how you could use graphs on top of JSON data stored in relational tables. And then last but not least, we execute SQL graphs queries by translating them to SQL. So we leverage all the performance advantages and all scalability advantages of the underlying SQL engine. Right. So this was a quick introduction to the to why graph and a quick introduction to the feature. But let's now see with a simple example what actually this feature is about and what you can do with it. So let's assume we have these three tables: customers, movies, and then customer sales that model the fact that customers rent movies. So schematically, you can see this relational schema as the graph on the right. So you have two types of vertices: customers and movies, and then the edges, cost sales, they model the fact that, as I said, customer rent movies. Okay, so for creating a property graph on top of this relational data, we will give support for the following create property graph syntax. So users can now write the syntax you see here on the right, which basically starts with the create property graph keywords, then the name of the graph. Then users can specify the tables, which are vertex tables in the graph, in this case, customers and movie, and the edge tables that are involved in the graph creation. And then for every edge table, we can specify what is the source and what is the destination of the edge table. Right, so what I want to mention here is if the underlying data schema has defined primary key and foreign key constraints, this graph DDL syntax works out of the box. So this is a very simple way and concise way to define a graph view over your data, right? As a reminder, as I said also in the, slightly before, this doesn't involve any data copy. It creates essentially just metadata over your original data. Right. In addition to this, we are also providing a more explicit version of this syntax. For example, users might want to, choose which columns in their underlying data they expose as a key of every vertex and edge table. They might want to choose which columns from the underlying data they expose as properties, right? Because you might have some columns which are sensitive in your data. You don't want to expose them necessarily as a property. So you can decide which properties you want to expose. And then you can define expressions and expose them as properties in the graph. And as I said, like for the edges, you can pick, what columns should be involved in the in defining your notion of edge relationship in the graph. This is very useful because not necessarily all the tables have primary key, foreign key constraints, mainly external tables. They don't have such constraints. So we want to allow people having this kind of data to integrate it in the graph. Okay. And notice that all this syntax is actually part of the SQL standard extension for property graphs. Oracle is providing an implementation of it. So now that the graph has, that we have seen how one can create a graph, let's see how one can query the graph using the new graph table operator. So the new graph table operator will appear in the from clause of the query. It takes as input a graph name and a match pattern. This is basically, you can think about it, the shape of paths you want to find in the graph, a set of conditions, basically those can be conditions on vertex or edge properties, and then a columns clause where you actually specify from the graph, from every vertex and every edge, what do you want to project out. The result of the graph table will be a table, which is then queryable in the rest of the SQL. So you can run group by, order by, you can join with other tables and so on. So graph table operator is fully integrated in SQL. Okay, so in order to understand how this operator works, let's see a simple example. So we will use the previous schema we have introduced, to answer this following query. So we want to find all 2 customers who rented the same romantic comedy movie, one after the other, and after a certain date, which is 14th of February. So in order to answer this query, one will write the following query. We will start with select star from, we will start by specifying graph table operator and the graph name we want to query, in this case, movie rentals. And then the next part is to specify the shape of paths I want to find in the graph. So if you remember, like the query says here, we want to find 2 customers. So customer 1, which with these open parentheses and close parentheses, I can specify that this customer 1 is a vertex, and then customer 2 is another vertex, and then they should be connected to the same movie. So I specify the movie, and then I connect customer 1 via edge 1 and customer 2 via edge 2 to the same movie. So as I said, literals between open parentheses are vertices, those between brackets are edges, and then every vertex and an edge can have a label constraint so that we can assert for what type that vertex or edge should have, right, in terms of labels. Right, so once the path pattern is specified, we can put conditions on both vertices and edges. So we wanted, like the second rental to happen after the first rental. The movie type should be romantic comedy, and then the first rental should happen after 14th of February 2022, right? And then we can also decide like what data we want to project out. In this case, I just decided, yes, we want the name of the 2 renters and the date of the first rental, and then we can order by the date of the first rent, right? So this basically shows very quickly how you can construct a graph query that answers this very simple question. Right, so now that we have learned a basic functionality of how we create graph, how we query it on a very simple example, I want to highlight some more interesting or more complex functionality, again, on a real life example, right? So let's assume we have Bob who wants to take a loan to buy an expensive house in New York. And then the bank would like to investigate the creditworthiness of Bob. So to do that, the bank will start to ask some questions and then investigate data about Bob. For example, the bank might want to understand, from the Bob social circle, like friends of friends or friends of friends of friends of Bob, what is their creditworthiness, right? The bank might want to understand whether Bob has any creditworthy work colleagues in his social circle that might be able to recommend Bob and vote for him, right? And then Bob moves to New York, so the bank might want to understand whether what are the chances or the likelihood of Bob to socially integrate there. So it will check whether he already has some people in his social circle who work in New York, right? So let's see how, using graphs on top of relational data, one can answer those questions. So first of all, let's see what the underlying schema could be. So the schema could be composed of some tables, for example, persons, companies, and places. And then persons can work at the company. A company can be located in a place. A person can know another person, or a person can adore a place. This is very quickly what this table creation syntax show here. So schematically, you can see, you can visualize those tables as a graph on the top right corner of my screen. And one thing to notice here is this person table basically has a column that stores JSON data. And then we will show how the graph can also incorporate that data. Right, so in order to create graph on top of these basically 5 tables, one has to write the following VDL. So this is very similar to what you have seen before. The main difference is that one can use, for example, the main difference is that one can use this simplify.json notation to expose properties from the JSON column of the person, right? So person is a vertex table, and then I can use the JSON dot notation to expose properties stored in that JSON column as properties in the graph. So for example, here I want to, let's assume that the JSON has a credit score field. So I can, access that credit score field. Let's assume that stores an array of value. I can run average on top, and then I can expose that as a graph property. So this shows how, graph can leverage data stored in JSON column. So you can really define graphs over both schema full and schema-less data. In addition to this, one thing to notice is that some of the tables, like persons, can be at the same time both vertex table but also edge table. Why? Because the person table had a primary key, foreign key relationship with the company, right? The person can work a company, so we can expose the table person as an edge table, right? So once this DDL is created, once this DDL is executed, then the graph you see now on the right side of my screen will, schematically, you will get a graph which will have the schema that you see here. One thing that I want to mention is that the underlying tables on top of which the graph is defined can be normal data tables, external tables, or materialized views. So we really allow people to incorporate data coming from various different sources. Okay, so now that we have created the graph, let's see how we can answer the queries that we have introduced at the beginning. So first of all, we would like to understand whether the friends and friends of friends and friends of friends of friends of Bob are credit worthy. For this, one can now write this SQL with graphs, where the main thing to notice is the match pattern, right? So what does the match pattern says? It says basically that we want to start from a vertex P, which is connected via a node relationship to a vertex F, and then the node relationship can repeat between 1 and 3 times. So this is what we call variable length querying, because you start from a vertex and then you explore everything which is between min and max, here 1 and 3 hops away from the originated vertex. We can put a condition on the name of the originating vertex, here Bob, and then once we find the vertices, the vertices F from friends, we can project their name and credit scores so that the bank can investigate them. Right? Schematically, the match pattern we have described here, you can visualize it on the right side of the screen. Right, so let's see the second query. So we wanted, work colleagues who can recommend Bob. So again, the query can start in a very similar way as the one before. So we start from a vertex P. We want to find all people in the social circle of P. We call them F. And then we want those people to work in the same company So we just write down here, okay, P should work at the company C, and then F should work at the same company C. So with these very simple 3 lines, we basically model a very complex querying, if you think about, because first of all, we model the social circle aspect. So P connected to F via 1-3 hops, and then we assert that the vertices that we found, they are all ending up working at the same company. And then on top of that, as I said, we can have conditions on their properties, like we wanted the work colleague to be credit worthy, so we can assert the fact that the credit score should be greater than some value. Maybe I put here 750, and then we can project values of their properties, like the name, the city, and the average credit score. And then because all of this is integrated in SQL, afterwards we can just order by average credit score, and then select the properties of our interest. And then the last query it's something. It's about finding friends of friends who of Bob who work in New York. So this is again something very similar to before. So we want to start from P, find people in his social circle by doing 1-3 hops away, and then those friends should work at the company, and then the company should be located in a place called New York. So again, the match pattern allows us to, very easily define the shape that we want to find. The where clause allows us to put conditions on every vertex or edge in the shape. And then the columns clause will give us the information we want to know on the resulted vertices of these queries or edges, right? So now I hope that I convinced you that graphs are a powerful tool to traverse the connections in your data. Again, this is mainly because with a very concise and intuitive syntax, you can define pretty complex traversals. And this is not all, right? Graphs are now another SQL object. So what does it mean? It basically means that all the security features of the database are available out of the box on graphs. So you can define privileges, you can define data guard reduction, data vault, you can audit graph objects. All these features are available out of the box. So all the security umbrella of the database will work for graphs. They are interoperable, like I said before, with SQL. So you can, join them with other tables. You can create views or materialize views on top of the result of graph queries. You can define triggers on graphs, etc. And then there will be full support for, data pump regarding import and export, right? And many others. Basically, every feature which is, working with SQL objects in general will work with graphs, right? And then this is not all, right? So because graphs are just another SQL object, all SQL applications will be able to leverage graphs out of the box. And then I just want to quickly show you how one could, build an Apex application from the previous examples we have seen, right? So as any Apex developer, what you can do, you go to your page designer, you pick the widget of your choice. For example, I picked here an interactive report, and then you are prompted to, choose a data source for the widget you want to include in your page. So here, what I have done is that I have put one of the queries you have seen before, right? So we are looking at social, credit score of people in the social circle of every vertex P, and then I want to project the name of the vertex P and the name of the people in the social circle with their credit score, right? So once I do this, I can now run my Apex application and visualize results as any other Apex widget. So I will get an interactive report which I can filter on, the source person name to be Bob. So I find all the people in his social circle and their credit scores. I can, decide which ones are credit worthy, which ones are not, or I can visualize this result in a different way, like a chart. Really, all Apex functionality will be available. So this really shows, how you can use graphs with all existing applications that are based on SQL. Right. So Oracle has been named a leader in terms of graph data platforms. This has happened 2 years ago. And this year, to add on top, basically, Oracle is the first company that implements the standardized SQL extension for property graphs. Right. So this will conclude my presentation. So in summary, what we have seen today is that graphs are now available in SQL. What does it mean? They can be created and queried in SQL. Graphs give you a powerful tool to identify connections or dependencies in your data and query them. And because they are available in SQL, all SQL existing tools and programmatic interfaces will work with graphs out of the box. Last but not least, as I said, this is a 23C feature. It will be available on all DB Cloud services and on-premise. So I welcome all of you to try it out. So this was all. Thank you, everyone. And then in case of any questions, feel free to contact one of the names listed in these slides. Thank you, everyone.